let's look at example 2. We're going to make a table of values, then we're going to plot the function and compare the results, just like we did yesterday when we were graphing 2 to the x and some variations on that. So this time we have f of x equals e to the x, and once again, just like yesterday, we can go to our calculator and have us help out a little bit with that. We can go to the y equals, and the e to the x, you can't see it very well on my screen, but it's on the ln button. Inspires have their own e to the x button, but for the rest of us, we have to do second and ln. So there's the e to the x. And we can look at the picture. We're going to be graphing it in a minute. But there's the picture of e to the x. And the values that we have in our function here, when we look at our table, they're not going to be very that nice of numbers. As you can see, lots of decimals in them, and I think I started at -2. So we fill in this table, and we have -2 is 0.13, and -1 is 0.37, and 0, 1, and 1, 2.7, and 2, 7.4. Just copying them off of that table, but the key is, do you know how to type it in your calculator? So when we come over here and graph, we have -2, which is 0.13, -1, which is 0.37, 0, 1, 1, 2.7, and 2, 1, 2, 3, 4, 5, 6, 7.4. And there's a function. And we saw the picture a moment ago. And what we want to know is, well, what's the y-intercept on this graph? Well, 0, 1. Do we have a horizontal asymptote on this graph? And just like yesterday, we do. It's the x-axis, and the equation of that is y equals 0. Did our domain change from the front? Nope. Domain is still going to be all reals. And did our range change from the front? Nope, it's everything above that purplish line, so it's going to be 0 to infinity. But 0 is not included. It has a parentheses on there. If you look at your table, if you start studying the table, which is easier said than done for me, as you scroll through the negatives, over here to the left of our graph, these numbers keep getting smaller and smaller. In fact, they probably turn into scientific notation pretty quickly. But now that we've seen that parent function, let's take a look at a variant on that, which is g to the x equals -e to the x minus 3. What does the negative in front of the function do to the function? How does it flip? Yeah. Flips over the x-axis. And then, what does the -3 in the exponent, or how does the -3 in the exponent move our graph? And I think that it is right 3. But let's type it in our calculator and we can check and see. We still have the other value in there. But and what I would do to check it, by the way, is I would say second ln, I wouldn't put the negative in, I would just do the x minus the 3 to start. Did we move right 3? Yep. Now the one thing that I didn't type in, so we have to go back and type that in, is if we go in there and add that into our second equation here, second delete gets us to the insert, so we can insert a negative in front of the function, and now we'll actually have there's our original, and then there's our new picture. And really what we want to know are a couple of values so that we can actually get this graph. So I'm going to turn off the first function and look at the table. And here's some values for us. But it seems logical just from talking about that last one, how small those values are. We have negative 2.006, negative 0.0067. And we have negative 1, negative 0.0183. We can't even tell a difference on our picture here. We can't graph that small of a number. 0 is negative 0.04. 1 is negative 0.13. 2 is negative 0.36. 3 is negative 1. And now we at least get some changes here. 4 is negative 2.7. 5 is negative 7.3. 1, 2, 3, 4, 5, 6, 7. But hopefully, roughly, we get the idea of our picture from looking at the screen. And before I erase this table here, what is the y-intercept on this one? We definitely want to look at it on the table. So remember, the y-intercept has x equals 0, so this is roughly, it's 0, negative 0.05, if we round there. Do we have a horizontal asymptote? And it still seems to be the same value. Here on the x-axis, which once again, our equation is y equals 0. What about our domain? Well, still all reals. We can pick any value for the x. Domain, when we have a fraction, we need to look a little bit more closely. When we have a radical, we need to look a little bit more closely. We don't have either one of those things. Now our range on many of our problems so far has been 0 to infinity. It is not 0 to infinity on this particular problem. If you notice that everything is below the purple, and this time it's going to be negative infinity to 0. Do this here. So to finish, here, let's graph the inverse of e to the x. And again, let me remind you that inverse means that we're going to switch the x's and the y's. And not only do the x's and the y's switch, but our domains and range switches as well. So when we come over here to graph this, then I'm going to have 0.142, negative 2, negative 1, 0, 1, 2. And then we have the 0.37, the 1, the 2.7, and the 7.4. And it says draw this graph along with f of x equals e to the x. But I'm going to graph it right now. Do the best that you can. I know that it's really a small amount. 0.14, negative 2. And 0.37, negative 1. And 1, 0. 2.7, 1. And then finally 1, 2, 3, 4, 5, 6, 7.4, 2. But it looks remarkably similar to our example from our front of our notes. The equation for this inverse, and it goes back to the base there. The equation for this inverse is actually y equals the natural log of x. One of our parent functions that we did earlier in the year. And when we look back to the domain here from f of x equals e to the x, our domain is all reals, which means on this our range is going to be all reals. And our domain from our range from our original problem is going to be our domain, 0 to infinity, for this picture, which makes sense because it looks like we have a vertical asymptote. And I kind of give it away because we do have a vertical asymptote. We had y equals 0 for a horizontal asymptote earlier. So this must mean that we have x equals 0 here. We have a vertical, which means that we only have an x-intercept, and we had the y-intercept earlier, but this one is 1, 0. Again, it flipped as well. The x and the y flipped places. That's the whole idea behind inverses. And then lastly, at this part here, it says inverse functions reflect over the line. Well, it's still the same one as before, which is y equals x. And that line, again, goes from the lower left-hand part of the graph to the upper part of the graph. And we can put our earlier picture on here as well, so we can really have a visual picture of the idea that they reflect over. And what we had is we had -2, 1.4, and -1, 0.37, and 0, 1, and 1, 2.7, and 2, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, here. And if you're really looking at the points, you see that all that happens is they switch places.